Alright, problem number 2. Words that read the same backwards and forward are called palindromes. How many three-letter palindrome words are there that consist of a consonant, vowel, consonant sequence? And a couple little caveats here are that Y is we're going to consider Y a consonant for this problem and not a vowel. And also, the words don't really have to be real English words. They can be, made up words like Y-U-Y or, things that, you get X-I-X. I guess we'll consider it to be a word. So, if we assume that, let's take a look at what we've got. We've got 3 letter positions to fill. And let's figure out how many choices we have for each of those letter positions. So in the alphabet we have 26 letters, right? And 5 of those are vowels, right? A, E, I, O, and U. And sometimes Y, but we've already said Y we're going to consider a consonant. Alright, so how many choices do we have for this middle position if it has to be a vowel? Well, obviously we have 5. And if these two have to be consonants, then we have 21 consonants left, right? So we have 21 choices for this position, and whatever we choose for this position, that is going to determine what is in this position. So really, we only have one choice for this last position, right? So if we choose P for this position, then this automatically has to be P. We don't have a choice because we're looking for palindromes, right? So, how do we figure out how many words satisfy this condition where it's 3 letters and it's a consonant, vowel, consonant sequence? Well, we can just multiply 21 times 5 times 1, and that'll give us our answer, 105, right? Now, if you've done a lot of these types of counting problems, you probably see that automatically, but if you haven't done a lot of them, you can always visualize it by looking at a tree. So we have, so if we are going to choose the first letter, we'd have 21 choices, right? We can choose A, we can't choose A for the first one, can we? What am I thinking? We can choose B, or we can choose C, or D, or F, and so on, all the way down to Z, right? There'll be 21 of those. And then for our second letter, we have 5 choices for each one of these, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, if I'm going to draw a tree. This is hard to draw because, I don't have enough room. So, but each one of, once we have the first consonant chosen, we have 5 choices for the vowels, right? So if we were going to draw out a tree that represents, each branch of the tree would represent the word, then, so this is a consonant, and this is a vowel. So we have 21 consonants and 5 vowels, so each one of these 21 consonants will have 5 branches off of it. So that's how we get the 21 times 5. And then for the last consonant, we only have one choice because it's got to match whatever consonant we chose for the first, right? So this could be, our first branch here would be B, A, and then this is automatically B, right? And then we'd have E, so we'd have B, E, and then B. So we could draw those all out. That would take a lot of time because there's 105 of them, right? So it's good to know this rule for multiplying. It's actually called the fundamental theorem of counting, I believe, where it says, if you have, so many choices for one thing and so many choices for another thing, you can just multiply to get how how many ways to, how many choices you have for everything combined. I don't know if I said that very well, but so anyway, the answer is 105.